That's a super volcano that is a continent killer, and it blows every 600,000 to 800,000 years, and everyone dies.
Yellowstone is not a stranger to geological activity, being one of the most well-known geothermal hotspots in the world. However, in the last several days, an extraordinary and horrifying discovery has been made that has rocked the entire region. A strong earthquake shook the park late one evening, agitating the serene surface of the well-known Yellowstone Lake. Thought to be a small tremor at first, it really signaled the beginning of a string of progressively powerful seismic events. A deluge of hundreds of earthquakes struck the park non-stop for the following 2 days. Initial investigations indicate that these seismic events are not coincidental. Such a move would have disastrous consequences. As the quakes continue, the fear of a catastrophic volcanic eruption looms large. Is the enormous earthquake swarm occurring in Yellowstone a sign of an approaching supervolcanic eruption that has the potential to completely destroy the continent? Join us as we explore the terrifying discovery at Yellowstone that leaves residents running for safety. Yellowstone's supervolcano, a sleeping giant, has the potential to unleash devastation on an unimaginable scale. The public and scientific community are on high alert because of the terrifying prospect of such an eruption. Once lauded for its tranquil beauty and natural marvels, Yellowstone is now a terrifying landscape. On August 29, 1870, a 30-year-old Army lieutenant by the name of Gustavus Doane climbed Mount Washburn, which was located above the Yellowstone River, as part of an exploration mission in the Yellowstone region in Wyoming Territory. As he peered south, he could see that a section of the Rocky Mountains was devoid of mountains. The only hills for what seemed like an eternity were off in the distance, encircling a massive forest basin like parentheses. For Doane, there was just one possible explanation for the absence of substance. The Great Basin, according to him, has been formerly one vast crater of a now extinct volcano. The lieutenant was correct. Yellowstone is in fact a volcano, and not just any volcano. The oldest, most famous national park in the United States sits squarely atop one of the biggest volcanoes on Earth. On the other hand, Doane was incorrect in one very important regard. There is still life in Yellowstone's volcano. It is still very much alive to a disturbing degree. Supervolcanoes are a whole different ballgame from regular volcanoes. Some scientists use supervolcanoes to describe extremely violent and loud explosions. But there is no universally accepted definition of the phrase. Any eruption that ejects more than 240 cubic miles of pumice and ash in a single event is considered a supervolcano, according to the U.S. Geological Survey. This is more than 50 times larger than the notorious Krakatoa eruption of 1883, which killed over 36,000 people. Supervolcanoes flatten mountains that have been formed by volcanoes. Volcanoes wipe out life for miles around, while supervolcanoes alter the climate on a global scale, threatening the extinction of entire species. Even though no supervolcano eruption has ever been witnessed by humans, scientists have managed to reconstruct the characteristics of such an explosion. At first, hot steam rises from the Earth's interior and melts rock just below the surface, forming a huge chamber that is filled with a pressured mixture of magma, semi-solid rock, and gases such as carbon dioxide, water vapor, and others. The ground above starts to rise up by a few inches as more magma builds up in the chamber over thousands of years. As if someone were slicing a hole from under a wooden floor, cracks appear along the perimeter of the dome. An enormous runaway reaction occurs when the magma chamber's pressure is released via the cracks, causing the dissolved gases to explode all at once. This is analogous to opening the Coke bottle after you've shaken it, as Bob Christensen, a U.S. Geological Survey researcher, who, in the 60s, was a trailblazer in studying the Yellowstone volcano. The surface gives way when the magma chamber is drained. The entire top area sinks into the ground as if the earth were swallowing itself. A massive caldera, meaning cauldron in Spanish, remains behind. Numerous eruptions spanning over 18 million years have occurred at the hotspot that formed the Yellowstone caldera. The eerie moonscapes of the Snake River Plain are formed by the subsequent lava flows, which are a result of ghostly calderas stretching out like a series of gigantic beads across southern Idaho, Oregon, and Nevada. This is all due to the fact that the hotspot is firmly anchored in the Earth and is being pushed southwest by the tectonic plate above it. Have you ever experienced an earthquake in Yellowstone? Even if you deny it, there was probably a minor earthquake when you were there. Every year in the Yellowstone region, there are an average of 1,000 to 3,000 earthquakes. Few are large enough to be felt, but those that are, like the infamous 1959 earthquake, are the exception. When it comes to seismic activity in the U.S., Yellowstone is right up there with the worst of them. Seismic activity in the Intermountain Seismic Belt, which includes the park, can be felt north to south across the states of Montana, Wyoming, Idaho, Utah, Nevada, and Arizona. Geysers and hot springs, two of Yellowstone's most recognizable surface features, are the product of the park's underlying volcanism, which is itself an active volcano. Rock breaks along fault lines that have been overstressed to their breaking point during earthquakes, which are frequently the consequence of a mix of tectonic and volcanic forces. The energy is subsequently dissipated in the form of seismic waves, which propagate rapidly through the adjacent rock and cause reverberation. One positive aspect of earthquakes is that they prevent natural phenomena like Old Faithful and other geysers and hot springs from being dormant. By keeping the plumbing system open, earthquakes in Yellowstone help to maintain hydrothermal activity. Mineral deposits may eventually seal off the tiny fissures and conduits that bring hot water to hot springs and geysers if earthquakes don't shake the earth periodically. In most cases, humans do not experience earthquakes with a magnitude below 3.0. Structures can only be damaged by earthquakes of magnitude 4.0 or higher, while the ground can only be ruptured by an earthquake of magnitude 6.5. Seismic events in Yellowstone over magnitude 6 are rare, although they do happen. The most famous and most tragic earthquake in the Yellowstone area happened 57 years ago. The 7.5 magnitude quake, which caused 18 miles of surface faulting and was felt across 600,000 square miles, decimated a popular campground at the height of tourist season. The worst nightmare came true for thousands of people on a late summer night when they heard the ground shake with an incredible force. The southwest Montana Hebgen Lake Earthquake, which had a magnitude of 7.5, occurred on August 17, 1959. It was the second biggest earthquake that the continental U.S. had in the 20th century when it happened. Even now, people may feel the aftershocks of this earthquake, which ranks among the biggest in U.S. history. Hebgen Lake is a huge artificial reservoir, and to the west of it, the modern-day Madison River Canyon extends for miles. Just beyond the line of sight from Highway 287 is the 1,914 completed Hebgen Dam at the canyon's head. The renowned blue ribbon fly fishing waters of the Madison River flow into and out of the lake. Prior to the quake, the Madison flowed from the dam outlet through a tucked-away canyon of the Madison Range toward Ennis. On either side of the timber-laden valley sat steep slopes coated with rocky outcroppings and dense forest. At the foot of the canyon, the river dropped in elevation, entering the expansive Madison Valley. Just before the foot of the canyon sat Rock Creek Campground, a then popular resting ground for tourists visiting Yellowstone National Park. The first tremor didn't last more than a minute. A vertical 20-foot wall of bare earth was left behind when the earth slid downwards along the fault line in a matter of seconds. An enormous slab of loosely attached material broke away from the north-facing slope of the canyon shortly after the tremendous earthquake and dropped quickly into the valley, tearing trees and hurling stones, weighing thousands of pounds into ferocious chaos as it went. Several miles downstream from Hebgen Dam, a new natural dam was created at the base of the canyon when rubble fell to the floor. As the Madison River inundated the canyon behind the slide, it engulfed trees and campers, creating the foundation for Earthquake Lake. The Hebgen Dam was already in a precarious position when large waves, known as seiches, breached it. The inhabitants of Ennis were forced to flee their homes not long afterward due to the widespread concern that the dam might collapse. The night was filled with fear and mayhem. Scattered families fled through the darkness. Those who could scrambled for high ground as the newly formed lake rose to swallow their campsites and cars. Others, trapped by the rising water, screamed for help. It would be many long, dark, and terrifying hours before dawn, and it would be many days before it was known just who had lived and who was lost. The final tally was 28 fatalities, with 19 more believed to be trapped under the rubble of the avalanche. Officials evacuated hundreds of casualties from Refuge Point, an accessible but elevated point after the earthquake. Damaged roads and bridges were rebuilt, and debris was cleaned by the state. Much of the roadway was reopened in only a few days. It just took a few weeks to fix the Hebgen Dam, and it held. In Yellowstone National Park, thermal features experienced changes, including the Old Faithful Geyser, the park's most visited attraction. Before the quake, Old Faithful's average eruption interval was 65 minutes. Within 2 to 3 years following the earthquake, Old Faithful's average eruption interval increased to 74 minutes. Sapphire Pool, a hot spring in Yellowstone's Biscuit Basin that had been relatively silent before the earthquake, started erupting at a height of more than 200 feet within a few days. The eruptions destroyed the biscuit-like formations, the basin's namesake. Steamboat, the world's tallest geyser, located in Yellowstone's Norris Geyser Basin, awoke from its 50-year dormancy when it erupted in 1961, less than 3 years after the 1959 earthquake. From Highway 287, you can see the whole bare slope. The trees that once lined the Madison River now stand gray and waterlogged at the bottom of Earthquake Lake, protruding from the surface as a memorial of the landscape that used to be. The largest Yellowstone earthquake since the early 1980s occurred on March 30th, 2014. The magnitude 4.8 quake was centered 4 miles outside Norris Geyser Basin and was felt throughout parts of Montana and Wyoming. A vast geological monitoring system is situated within Yellowstone, although it is largely undetectable to the uninitiated tourist. Earthquake swarms are common in Yellowstone, say seismologists from the University of Utah, who run 26 seismograph stations across the park. Small earthquakes that happen in a concentrated region, often more than 100 in a day, are called swarms. Between Old Faithful and West Yellowstone, approximately 2,000 earthquakes were detected in the winter of 2010. Scientists are able to better comprehend and record the subsurface geology surrounding and under Yellowstone with the help of this extensive monitoring system. The last 3 super eruptions have been in Yellowstone itself. The most recent, 640,000 years ago, was 1,000 times the size of the Mount St. Helens eruption in 1980, which killed 57 people in Washington. But numbers do not capture the full scope of the mayhem. According to scientific calculations, the ash pillar from the Yellowstone explosion ascended to an altitude of around 100,000 feet, depositing a blanket of debris that extended from the western United States to the Gulf of Mexico. Aerial gray clouds of pyroclastic flows, which are dense, toxic sludge, rock, and gas, superheated to 1,470 degrees Fahrenheit, swept across the terrain. A thick, hot mass stretching hundreds of feet across the once verdant terrain bonded itself like asphalt, descended from the heavens, and filled whole valleys. And this was just the least violent part of Yellowstone. A nearly twice as powerful eruption occurred 2.1 million years ago, creating a crater the size of Rhode Island. A smaller but equally destructive eruption occurred between the two, around 1.3 million years ago. Each time, the whole planet would have felt the effects. Gases that rose into the stratosphere combined with water vapor to form a thin haze of sulfate aerosols that reduced the amount of sunlight reaching Earth, possibly causing a volcanic winter. Some scientists believe that our own species' DNA may have preserved evidence of this disaster from about 74,000 years ago, when a supervolcano in Indonesia called Toba erupted. After the eruption, there was a volcanic winter that may have triggered a worldwide chilling phase that nearly wiped out humanity, reducing the human population to a few thousand people. The supervolcanoes may have been violent, but all they've left behind is a subtle feeling of absence. Erosion, glaciers, and minor eruptions, the most recent of which was 70,000 years ago, have all contributed to filling the Yellowstone caldera with lava flows and ash. Any remaining wounds are concealed by tranquil woodlands. Unless you possess exceptional eyesight, like Doan, or are being hushed by a geologist, it becomes nearly hard to discern because of the cumulative impact. Meanwhile, the island of Santorini is hiding an explosive secret. The current day is still very much affected by the eruptions of the past. The Yellowstone caldera's nutrient-poor soils are ideal for the park's predominantly lodgepole pine trees. In a similar vein, grizzlies and black bears rely on the nuts produced by whitebark pines. Naturally, the land is still in a state of actual boiling over. The trout that ride in the rivers would not be so abundant without the warming effects of the hydrothermal springs at the bottom of frigid Yellowstone Lake. The park roils with geysers, fumaroles, mud volcanoes, and other hydrothermal activity. Half the geysers on the planet are in Yellowstone. The hydrothermal features change constantly in temperature and behavior, with new ones popping up in the forests, spewing clouds of steam visible from airplanes, and exuding vapors that have been known to kill bison on the spot. The features' temperatures and behaviors are also subject to regular modification. Despite Yellowstone's volcanic origins, the park went unstudied for decades following federal studies in the late 1800s. Afterward, in the late 1950s, Francis Joe Boyd, a young doctoral student at Harvard, became fascinated by welded tuff, a thick coating of heated and compacted ash. This formation indicated the existence of pyroclastic flows, which had occurred during a recent explosive eruption. Two separate welded tuffs were discovered by Bob Christensen in 1965, and a third was located the following year by him and his colleagues. They used potassium argon dating to figure out that the three tuffs came from three separate eruptions. All three eruptions left behind massive calderas, but the most recent one completely covered over their remnants. Then in 1973, while working on Peel Island in the south arm of Yellowstone Lake with a coworker, Bob Smith discovered something strange. Some trees along the beach were half buried and dying. In 1956, he had done some work in the area, and he intended to return to the same boat dock he had used then. However, the dock was likewise swamped. What was going on? In 1923, park personnel began placing benchmarks on different roadways across the park. Smith, intrigued, set out to resurvey these benchmarks. The Hayden Valley, located on top of the caldera north of the lake, had risen around 30 inches during the intervening decades, according to his assessment. However, the water level at the lake's base hadn't changed. It was as if the northern part of the lake had risen, spilling water into the southern part. The earth was trembling. There was life in the volcano. Smith published his results in 1979, referring in interviews to Yellowstone as the living, breathing caldera. Then in 1985, heralded by a swarm of mostly tiny earthquakes, the terrain subsided again. Smith modified his metaphor. Yellowstone was now the living, breathing, shaking caldera. Since then, Smith and his co-workers have exhausted all possible avenues in their quest to see what is beneath the park. The underground volcanic system's size and potential have been revealed gradually. By analyzing the propagation of earthquake-generated sound waves through different densities of subsurface rock, scientists have found that a massive plume of hot rock, rising from the Earth's upper mantle and tilted downward to the northwest by 60 degrees, with a base perhaps 400 miles below the surface, feeds the magma chamber. The ground rises as the plume increases the heat entering the chamber. Because little earthquakes release hydrothermal fluids to the surface, the pressure inside the chamber decreases and the ground begins to sink again. After the 1985 earthquake swarm, Yellowstone fell 8 inches over the course of a decade or so. Then it rose again, faster this time. Since 2004, portions of the caldera have surged upward at a rate of nearly 3 inches a year, much faster than any uplift since close observations began in the 1970s. The surface continues to rise despite an 11-day earthquake swarm that began late in 2008, causing a flurry of apocalyptic rumors on the internet. The enormous colossal then becomes, will it blow again? Some type of explosion is almost inevitable. It could be little compared to the 1991 eruption of Mount Pinatubo in the Philippines, which killed 800 people. The Hunga volcano, meanwhile, set out the most powerful electrical show ever recorded, with a power output hundreds of times that of an atomic bomb. After weeks of grumbling and spitting ash, the underwater caldera near the tiny kingdom of Tonga reached an unexpected fever pitch on January 15, 2022. In the world's largest volcanic eruption in more than 100 years, the Hunga volcano belched 2.3 cubic miles of molten rock and vaporized 146 teragrams of water, enough to fill 58,000 Olympic swimming pools. The resulting plume, which consisted of evaporated salt water, lava fragments called tephra, and volcanic gases, towered 36 miles high, nearly reaching space. Volcanologists were rattled, but by what? Early measurements revealed a massive lightning ring growing at a rate of about 180 miles per hour from the epicenter of the eruption. Volcanic lightning is well documented. Even Pliny the Younger mentions it in his account of the eruption of Mount Vesuvius in 79 AD. But I don't think any of us really expected to ever see a 280-kilometer diameter donut of electrical discharges, says Alexa Van Eaton, a physical volcanologist with the United States Geological Survey and lead author of a new paper on the Hunga event. Based on his findings, Van Eaton concludes that the eruption produced the highest recorded rate of lightning strikes, at 2,600 per minute at its height. That's twice as much as the previous record holder, a U.S. Southeast thunderstorm in 1999, when NASA counted 993 flashes a minute. And after combining data from several remote monitoring systems, she and her team believe they've reconstructed how it happened. Plume particles surfing a volcanic gravity wave created the perfect storm for record-setting lightning. Volcanologist Corrado Cimarelli of Germany's Ludwig Maximilian University of Munich said that since only a small fraction of the world's active volcanoes are under direct observation, scientists often rely on data gathered from other monitoring networks to piece together the timing and location of ongoing eruptions. Lucky for us, a U.S. weather satellite inadvertently snapped a photo of the Hunga eruption from above, so we could see how the plume was growing. However, the lightning detection mechanism aboard the satellite detected only infrequent flashes. Listening to the radio would allow Van Eaton to trace the lightning ring. Thunder isn't the only sound lightning makes when lightning streaks across the sky. Sometimes you see it pulse. You see it flicker a couple times, Van Eaton says. That pulse is electrons moving through a plasma channel, creating a powerful electromagnetic signal that manifests as both visible light, the bright flash, and radio waves outside the range of human hearing that can be detected thousands of miles away. 3 ground-based lightning detection networks picked up on radio waves from the Hunga eruption, and by meticulously combining their data, Van Eaton and her team were able to plot the location, intensity, and timing for more than 200,000 lightning flashes. Researchers attribute the unprecedentedly high lightning counts observed during the Hunga event to the massive injection of hot salt water into the sky, and the location data confirms this theory. A further peculiarity of the Hunga eruption was the presence of gravity waves. These waves are caused by the upward or downward movement of air caused by a trigger, such as a volcanic plume, which consists of very hot volcanic gases, ash, and evaporated water. When these waves are higher in the water than in the air, they separate the water into layers similar to oil and water. In this scenario, the plume is caught above the regular atmospheric layer. Thus, instead of falling straight down, the object's gravity compels it to spread out horizontally as it falls, resembling ripples in a pond. Particles of tephra in evaporated seawater are riding the gravitational wave. Rapid cooling occurs as water vapor ascends into the atmosphere, producing ice crystals and graupel, which are small, soft hail pellets. As they scrape against one another, the ice particles build up static electricity, creating what Browning calls Dippin' dots of electrical charge. While this ice charging process is also responsible for the formation of lightning. In a typical thunderstorm, the addition of silicate charging by tephra during volcanic eruptions gives the process a unique twist. Gravity waves, according to Van Eaton and her colleagues, are ideal for producing lightning because of their leading edge. Because of the wave's sharp edge, smaller particles, such as ash and ice crystals, may be pushed upwards by the force of the wave, while larger, denser particles, like graupel or tephra, may be pushed downwards, like surfers riding a wave. That facilitates the formation of separate charge regions, which in turn prepares the ground for lightning to rectify the imbalance. According to Bruning, the researchers have provided a compelling physical explanation for a puzzling occurrence that has baffled meteorologists and volcanologists. However, there are numerous unanswered questions. The lightning ring seems to fade away at one point, as pointed out by Van Eaton, but suddenly the donut hole is filled back up with thousands of flashes. Why care about volcanic lightning? Scientists have discovered that monitoring volcanic lightning could be a lifesaver when it comes to nowcasting when eruptions will occur. Because of the thick plume that forms during volcanic activity, satellites are unable to detect when an eruption has ended or when new lava jets are beginning to emerge. Real-time data will help scientists make better decisions about public health and evacuations as they gain a better understanding of how volcanic lightning forms. Ash from volcanic eruptions can cause problems for planes and the people living nearby. The question of when the Yellowstone volcano will erupt is a common one among tourists. That question remains unanswered. The current hibernation period may extend for thousands of years beyond the 70,000 years that have already passed. The likelihood of a complete caldera-forming eruption, a disaster that might cause the deaths of countless thousands of people and plunge the planet into a volcanic winter, is uncertain. It could occur within our lifetimes, or 100,000 years from now. Yellowstone will reawaken someday to host more eruptions, and if it does explode, perhaps some fortunate souls will escape unscathed.